Hello Professor, my name is Zehra. In this video I'm going to perform a laser diffraction experiment using a DVD and a CD to calculate their track spacing. Now let me show you the materials and equipments I'm using for the experiment. First I have a red laser pointer. It has a wavelength of 650 nanometer. Next I have a standard CD and a DVD. We will compare their data tracks. I'm using a clean sheet of white paper as my screen to project the diffraction spots. To measure the distance L and W, I have a standard metric ruler and I have a 45-degree triangle ruler. I use it to test and check if the CD and DVD are standing at the exact 45-degree angle. I have a stack of books. I will use these books to easily adjust and measure the laser height in 5 different levels. And finally, I have a small table which is used to support the CD and DVD securely at a 45-degree angle. Here is my setup. As you can see, the white paper is flat on the desk. The DVD is on the small table at a perfect 45-degree angle. I also placed my books here. I will change them to get 5 different heights for my measurements. Finally, the laser is completely horizontal on top of the books and points at the center of the disc. Now I turn on the laser. As you can see, the laser beam reflects from the DVD and creates bright diffraction spots on the paper. Because it is a DVD, the spots are very far apart, so we can only see 2 spots on the paper. I'm marking the centers of these 2 spots with a pen to measure them easily. Next, I measure the vertical distance L, which is the height from the laser to the paper screen. As you can see with the ruler, first L value is for 3.5 centimeters and I'm noting it down on my paper. Now I'm measuring the horizontal distance W between the central bright spot and the first order spot. I just measured it with my ruler and as you can see the value is exactly 9 centimeters. I have finished all 5 measurements for the DVD and my data table looks like this. Now we will repeat the exact same step for the CD. Here is my setup with the CD. It also fixed at a 45-degree angle on the small table. Now I turn on the laser. As you can see, we have the diffraction spots on the paper again, but they are much closer to each other this time. First, I'm marking the centers of these diffraction spots on the paper so I can measure them easily. Next, I measure the vertical height L from the laser to screen. As you can see on the ruler, the value is 3.5 centimeters. And now I'm noting this L value. Now I'm measuring the horizontal distance W between the doors. According to my ruler, our distance is exactly 7.5 centimeters. I'm noting this W value down in my notebook as well. I will repeat this for 5 different heights, and just like the DVD, we will use exact same formula to do all the calculation for the CD. I have finished all 5 measurements for the CD and my data tables looks like this. As you can see, I use the exact same height values for both the CD and DVD. The reason for this to create a controlled experiment. By keeping the vertical height L constant, we can clearly compare how the track spacing affects the distance W under the exact same conditions. In conclusion, we saw how the laser dots look like different on a CD and a DVD. Thank you for listening to me, Professor.